Good afternoon. So I want to break the promise I gave that we shall do examples and probably try to rise through so that I can cover the multivibrator for at least the last practical. Those who will be doing it to be able to know what they are doing. Okay? These are just examples. Once we are done properly, we just be able to get it. There's a lecture, whole lecture of about 30 minutes, just about the math maps. So we had looked at other representations of logic functions, like if you use mini terms using the summation. We did the same for the F and E functions we had. And then now we go to the canonical product. Canonical product. A product of sums. A product of sums. Product of sums. Is used in this canonical. Yes. Huh? Okay, 2. Sorry. 2. What? Number 2. It is 2 here. I thought we had, because I don't know why I was, but it's 2 here. I'm also tired. If you are tired, I'm also tired. I'm not a machine. Some of you are looking at me as like, now this man. I'm also tired. Since January, we've been dancing around, isn't it? So I'm also exhausted, but I have to finish, okay? Does that make you happy? You have a fellow tired person? We are in this together. Eh? And for you, when you go for holiday, me I'll be again marking you. When you are busy showing off to those kids in secondary, me I'll be busy marking, looking for where you made a mistake. I don't enjoy marking, I can tell you that. Eh? It's the worst thing I find in my profession. I just ask you what I gave you and you start writing nonsense. And my job is to look for where you are wrong. I don't care what is right. Hey, and it is not this one, take it from me. Your passing is just a consequence. I'm not here to make you pass. It is a consequence. As I remark and you have put whatever I ask, then you get your 9. I don't come to your paper and say, I want my students to pass. No, that's not my, it's not my objective. Mine is to look for mistakes. Oh, no mistake here. No mistake here. No mistake. Hey, there is a mistake here. And then I count where there was no mistake, and then you get marks. Does that make you careful to work hard? No, you don't want to. You don't want to work hard. So the product of sums POS is used. We use the product of a sum of products when we are looking at the other representation. And the canonical product is the algebraic product. The canonical product is the algebraic product. Now you know the word algebraic, I think. max terms, or maximum terms, corresponding to the input, combinations, for which the logic function is 0. So in max term notation, in maximum term notation, the procedure is that where we have 0, 0, 0 for the variables a, b, c, then it is repeated as a or b or c. And where we have 0, 0, 1, that is it is c, which is not. It's like an inverse of what we had for the product, sum of products. So this would be a or b, and this one, because these ones became the variables when they are 0 actually, when they are null or when they are negated, because round would be negated. So here where we have 1, then we have the C bar. To mention but a few. Hence, for the example we had, f would equal to where we had zeros. I don't remember the thing, but we can do here zeros, A, B, C, F, G, 0, 0, 1, 0, 0, 1, 0, 0, 1, 1. I want you to practice this and make sure that you do it without an effort. So now 1, 0, 0, 1, 0, 1, 1, 0, and then 1, 1, 1. And we say C, F is equal to C, 0, 1, 0, 1, 0, 1, 0, 1. This was 0, 0. This has no deal, but all the other ones will be 1, 0, 1, 0. So in this notation, whereby when we have 0, 0, 0, we get the, so it's like where we have the function giving us law. So that means it would be A or B or C, if we equal to A or B or C, and then we have, so this is a product of sums. The other one would be where we have a 0, this would be A, not B, C, and the O's. So it is A, or not B, or C. Then we do a product of this part here, which is not A, or B, or C. So not A, or B, or C. We go to the last one. Not A, not B, C. Or, okay, not A, or not B, or C. Not A, not B, and then O, C. And G, where it is 0. Where it is 0, there are many. We have the A or B or C. A or B finally we have node A or node B or node C. So if you have to represent as the sum of products, then you look for where it is high. Then the product of sums, you have to look for the function when it is low. And then since what is low is what you take as an issue, then that's why we are having the A or B or C for when we have ground, because that's what is giving you meaning at the end of the day. Because the canonical product is the algebraic sum of max terms corresponding to the input combinations for which the logic function is 0. The logic function is this for which the output, when we say this, the logic function is the output. This is the logic function, which is equivalent to an output. And then the variables, these ones here, these are the input variables. Input, or simply logic variables, to sound nice. These are the logic variables that culminates into a logic function. Third representation, we can use the product's notation. We had a summation notation, now we can have the product. What is the symbol for product? Summation is sigma, this one here. This is the summation. The other, if we talk of the product, is what? Pi. So this one will be the product. So max term list, the maximum term, the max term list using the pi notation or the product notation. And since f is equal to 0, because that's the max term we are taking, so since f is equal to 0, when we have these are the things that give an f which is 0, so that means that if we put our decimal here, our decimal number, if you remember, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. So since the function f is, the logic function f is equal to 0 for the combinations, for the input variables a, b, c being when it is decimal 0, at 0, f is 0, at 3, 0, we started with 1, no, we were supposed to start with 0. Supposed to be starting with 0, then 1, 2, 3, 4, 5, 6, 7. These days you are like letting finish. If I make a mistake, I say, let him suffer, we finish. Just 2 weeks, let us finish strong, eh? Don't leave me in my movie. This is 0, then 2, the even numbers are the ones which give. So it will be 0, 2, 4, 6, 0, 2, 4, 6. And so we can write it in a nice way and say that the function f can be represented as products of the variables a, b, c for the from 0, for 0, when it is 0, 2, 4, and 6. Similarly, G is 0 when we have this one, this one, this one, this one, and this one. So when they are odd is when we have G giving us max terms. I mean when it is 0.
What about Z? What about Z?
I put a wave. Then this is a wave. I put waves.
Yes, but you have said that G gives us the value we want when it is odd.
Okay, sorry. But starting from 0. Starting from 0. So this is P would equal to pi, ABC, and then we have 0, 1, 3, 5, and 7. I like Mugabe for one thing. He throws it as it is. Well, you know, you sometimes become nice. Even when I'm seeing you chatting with people, it's like some of us where we come from, they say when even we are chatting, it's like we are quarreling. So, I don't know whether where you come from is the reason why I don't know where you come from. I've seen him when even chatting with friends. Don't feel bad, I'm just giving the truth of the matter. You see him it's like he's complaining. No, we have to go for a lecture. But, okay, so then we have the similarity between it's now like the opposite. Summation, we took summation of sum of products when it was 1. We took now we are taking when it is 0. And when you look closely, they are like interchangeable. Like what was the pi is actually giving us the values for when it was sum of the product. So similarity between many terms, similarity between the many terms term list and max term list. Hey, I had forgotten. I wanted to rant. I think you need to be nice to me. Last time I complained that you leave tea bags in the sink. And we have two trash cans. We have a small trash can in the lab. We have a big trash can outside. When you get a bunch of the when you boil a lot of water, you have to empty that kettle in order to make sure that it does not rust if you keep the water in there. Otherwise, if you boil the water and then you leave it there, then it is not the best that you will do. You can sit and attend. It's like when you went away, you miss our lectures.
Even us.
You can give her a chance to attend with us. Who advised you to leave? Okay. Since it is is yours off, we cannot complain. So we can switch between the two by looking at the similarity between these two lists. E.g., we have that F is equal to pi ABC of then 0, 2, 4, 6. F was equal to summation of ABC 1, 3, 5, 7, which should be equal to pi ABC 0, 2, 4, 6. And then we have G equal to summation ABC, which is 2, 4, 6. And this is the same as pi A, B, C, 0, 1, 3, 5, 7. This one I'm not over explaining is this is how you can express either way of the two. Maybe when I teach well, I can't promise. The reason we got slow is because of how I had to take an initiative and go through Tevenins like 3 times so that you understand those bits. But we are on time. If I keep saying that. This is the second last week or last? Okay, so we have now an idea about logic variables, and once you know how the two relate, you get logic function. Now, if we have a combination of logic functions, then we make a family. We make a family of functions which do a couple of give us a couple of operations and relate it in some way, and then do and get an output which we want. So we look at logic families. A logic family is a collection of different, is Agaton here and Mabilizi? Yes, Agaton is here. So what you were doing yesterday, and maybe partly the false, what you were doing yesterday, combining a couple of ICs, you were trying to work out a logic family. So a logic family is a collection of different integrated circuit chips that has similar input, similar output, and the nano circuit characteristics. but that performs, since there are many, but that perform different logic functions. Before I go to the second sentence, those of you who have done D1 and D2, the chips look the same, okay? They have the same place for VS or VCC for 5 volts. They have the same place 7 for where you put the grounding, but they probably inside you feel like as if the whole thing looks the same. But then you actually get one giving you an AND, you get the other one giving you an AND, you get the other one giving you OR. But they have the same inputs. You find that leg 1, leg 2 will be input for that gate, leg 3 will be output for that gate, and other gates, since there are about 4 of them in a particular gate. But then, the 7400 will give you an AND, the 7408 will give you, I don't know which one, I can't have it in my head. The 7402 will give you a different thing, etc. You get the idea? This is what this kind of statement means. So chips from the same family, not the chicken and chips. Chips from the same family, chips from the same logic family can be interconnected. Can be interconnected, and Paul did a lot of that. So are the agatons. It can be interconnected, but chips from different families. But chips from different families, may not be compatible. From different families may not be compatible. Compatibility is always the problem within electronics, and this is due to different power supplies, different input, input and output, different input and output conditions. Remember, we had the chip for which had 8 legs. The chip for the operating amplifier. You have the output there, then you have the NAR, and then you have another one which is not connected. No, this was the 7 positive 12 volts or 7. No, it's leg 7, not. So 1, 2, 3, sorry. And then the other one was, we have these 2, and then we have 1 there, and then we have, I think one which is now, so you start from 1, 2, 3, 4, 5, 6, 7, 8. I think 8 was not connected. And then this was the plus 12 volts. And then this one is minus 12 volts or minus V, not connected. And then you have this one as input, input 1, input, okay. This was B differential voltage. So here differential input. So this one was V. This is plus. This is minus. So this is VP, VN, and this is I think which one is grounded? Whichever you will check. Now, if you compare this with the D1 and D2 chips, then you find that it is a different family because the D1 and D2 chips are logic gates, and these gates are 14 pins. You have the notch somewhere up here, and then you have the 14th. So yeah, 14th being the BS. And then you have 13, 12, 11, 10, 9, 8. And then you have the 1 here, 2, 3, 4, 5, 6, 7. And here you have the grounding. So 0, 0 supply, PS. And then depending on which gates you are dealing with, probably we have this one as if we can take AND. We have an AND here with an output here 3. Then this is 7. So you can't connect these two and you think you'll be fine. Because they have different chips from different families may not be compatible because they have different power supplies. This is getting about 5 volts. This is already 12, positive 12 volts. So how can you easily work with them? Otherwise, you would have chosen on a breadboard, my red line I'm going to put there 5. You add just the board, the breadboard voltage on the potentiometer, you get 5 volts. Now you find you want to have 12 volts for this. Now, what will you do? You are using the same breadboard, you have one supply. But the reason those breadboards were having 5, specifically 5, and the other one potential divider up to 15, so that you can actually have you can do practical, if you are, sorry, not practical, if you are doing a project where at one point you are having a use of an operation amplifier, and then at other section of your set you are using the chip for a gate, you should be able to get supply, 12 volts supply from the other potentiometer, and then you have official fixed 5 volts from the 5 volts whatever, so that you can work on your stuff. But in terms of if you were to have in a connection, you want to connect them together, then you lose out because of these different power supplies, you have different inputs. Here you are choosing an input 1 and 2, but here you have an input on 2 and 3 because of this differential voltage. So it becomes a problem because of these issues. And electronics in general, in terms of even applied electronics like your smartphones and the like, if you are having, many people I've met in workshops, you find them moving around looking for a cable when they have forgotten theirs at home, and everyone is saying, I'm using Android. And then nowadays someone is using an Android with this cable here, with the one which is like this, a bit like this, and then you find this is a C. You find this one, the C, I like the C because you don't have to care, you just push in the way you want. You don't need to know how to push it. When you pick it from the mains, from the socket, you just push in your phone. The other one, this one here, you have to first touch and see which flat part it is, and then you push it. I don't know why you are laughing. Excuse me. So, yes. Don't take me far way back.
No, that's the little way back. 20.
Yes.
So what goes in there? Like when does the chip become a chip?
Okay, good. So if the chip becomes a chip, when you get what we are going to do next, and then put it within the chip. So just give me a minute. I reach this part and then I show you how. These are just a few things, but there are other things which can make it, make this incompatible. And electronics is a drastic, I don't know whether that is the word, or dynamic, let's use the word dynamic. It's a dynamic field that as you are getting used to this phone, they bring another model. Before you have started posing with this model, they bring another model. I started with the Windows 98 PC, which I still have. Then came Windows XP, which I still have. Then came Windows 7, which I lost. Then came Windows 8, which I couldn't use because I was still using 7. Then came Windows 10, which I'm still using, and they are saying that now it will expire in October this year. But my PC is still looking nice. So I want to petition Microsoft and HP, since the computer is HP. I want to write a petition to the UN that these people are contributing to the e-waste. Do you know e-waste?
Yes.
Electronic waste, when you get those circuit boards, when a computer is old and you have to throw it away, those circuit boards have a lot of waste that is really dangerous and it is hard to dispose of. And it is because of their greed. My computer still looks nice. It's nice, they gave it to me because of Nwele. They said I'm using Nwele nicely, so they gave me it is looking nice. I have been handling it nicely. It is the one I used when I was presenting to you on Moon Viewing. Now you are telling me in October it will be obsolete just because I can no longer get updates from Microsoft. So it's as good as I should throw it away because the hardware is incompatible with Windows 11. So these people are contributing to climate change and go around saying that we want to fight climate change. So I want to make a petition so that they stop at making our computers obsolete from this year. The manufacturer should make it possible that that hardware should be compatible with any other OS, any other operating system that comes up. I don't care how you guys take life, me I take life serious. You cannot continue making me suffer when I can complain. I don't buy.
Related to that, there was a petition, 2 of them successful, about the battery.
Yes,
the inbuilt battery on the phone.
Yes.
Which means when the battery goes, you
throw away the phone.
throw the whole thing. So I think they won in the UK. You cannot have.
I feel I will win. Because when they bundled up my internet, I complained. People laughed at me that for us we are okay, we can use the internet we afford. People didn't know that we shall reach a point when COVID comes and then we have to be on Zoom for lectures. For them they thought the internet was for updating your status on Facebook, or by then WhatsApp had not come. Now, for me when MTN misbehaved, I told you, I promised that MTN will never get any money for bundles around physics. And they cannot. Are there some of you who use your MTN bundles when you are around physics? Yes. This place has no Wi-Fi. Yes, but once in a while when it is stable, you go on and use the one here. So I made them very poor, I think. And if I got money, I would make sure that everywhere there is a government outlet, I give a free router so that they also feel that their crew can be tough. Are we comfortable with compatibility? Okay. There is another word called in our operability, in our ability is like how the Kenyans are making their rail line, and then they stop at Kisumu, and then we have to make our own, it is called what? Standard gauge rail, and then when you reach there, you find these ones were coming like this, then you find ours is like this. This is what they call, because you may build when you are having a different reference frame, by the time you reach at the terminal point, you find that the train will have to, so you reach there. Yeah, but you see, it is not something that you go and then you make a corner like this. No, it has to come and join properly. So if they are not careful, they will build, and then they find. And this is what they mean by, if there is no inoperability, then you cannot use. And you find that if you are using, I don't know which other example I can use that you normally use. There's a times when you are using gadgets and you find that you cannot now use this gadget on the other one. Like now, there are some tablets you can't plug in anything apart from power cable. It has no phone jack, so you buy it, you have to be forced to buy these Bluetooth earbuds. If you don't have them, you just keep watching on the sound of the tablet, you cannot enjoy anything. And they do that to make sure that they can earn more money. So they know if they don't put that, now everybody will be forced to buy earbuds. So make sure this inoperability is a key thing. If you don't, that's why we use those two experiments, the E7 and E10. We use the old oscilloscope because the new oscilloscopes cannot give us some of the, like for E7, you cannot change the time base to be from this waveform to this, which helps you at least to get the peak to peak. When you change the time base to some frequency, then you find that you can be able to measure this part here. You don't care what is inside there because your interest is in the input peak to peak, and then when you have amplification, you get the output peak to peak, and then you find your value. So otherwise, we would wish to use a new digital oscilloscope on that experiment. But then so that's the idea that experiment wasn't compatible with the new oscilloscope, so it had to stick to the old ones. So we start with, since we are looking at logic families, we start with the diode logic. And I use this diode logic DL to explain the gates, the OR and AND gates. And the AND gate, we had two diodes which were facing this way, and then we supplied 5 volts. Savannah, where is Awin? You said you are friends, so I think I'm okay if I ask where is he? It's okay?
Yes.
How can he be okay when he's not
He has some challenges.
here? Okay, you don't say them here. Let us not say his challenges. So you know the reason. I don't have to really spend so much time here on how we ended up with A, B, Y, being ground giving us 0, ground 1 giving us 0, 1, 0 giving us 0, and then 5, 5 giving us light. I added on a LED to explain that, and then so this is the and then I can now answer Agava. They got these diodes here. Okay, what these diodes can do, and then they got it and etched it inside this chip and made sure that it sits there. And then sealed up everything, put the legs, and they gave us. So if it is an AND gate chip, they put 4 of them. And then on leg 1, this is where they put leg 1, they put leg 2 here, and leg 3 was of the output of these 2. Then you put another one, put another one, put another one, 4 of them. And then put where you put these 5 volts that will go to each of them to do the functions. And then grounded for the grounding where you will be picking a part that you can put to the leg.
So usually, like how many will be for something? Is there a size minimum?
I don't want to lie, I don't know. These things are done by robots. I don't know.
I know they can put many components.
So like if it is a diode, instead of putting these legs, because like there you see a lot of legs, and instead of making it round, they flatten it. I'm just giving what I would do if they told me to design. So if you flatten the diode and you make it smaller and you make it sit there, 4 of them, I mean 8 of them now, they would fit there. And then you use the few lines inside there to make those bits and then compress. And our robot will be able even to make it even smaller lines, put them there and then finish. I'm talking like that because whenever I would open those, something I miss. And when I went to the village at one point, I found that my toolbox was lost. But I had a lot of those circuits for the mirror watches with some dark thing like this, and then there were a lot of lines, coming out, and then they would put, you would see many lines here, and there was something like a rubber, as if it is rough, like a carbon thing, and then you would just get that, rub it a bit, and you know, like clean it, and then you would also clean the rubber, and then put it somewhere on the sunshine. Not put the LCD. You put the LCD, it becomes black. The liquid crystal just fills up the whole thing. If you are lucky, when it becomes cool, it comes out again. If you are unlucky, it stays there. Or one piece just goes there like a pimple in the whole thing. And once this has dried up, and I buy a new battery, a new cell, and I put in, the thing starts. And then I clean some other part, dust up, and then the owner comes and is like, hey, this son of so and so is very clever. And he gives me my money and I I have not done anything. Just open, clean the thing. Sometimes even it would be the battery which was dead. And when I put a new one, so the first is what they call troubleshooting. The first option, first put a new battery and see whether it works. It doesn't work. Then now clean it up. Then after putting it together, if it works, fine. If it works for the battery alone, you still charge your good money. And that's the beauty with trying to do things that many people don't do. Don't know. So I think I've explained how the chip becomes a chip. What I haven't explained is how this thing is done. But that video which I put, those videos which I put, there is one of the videos which is about semiconductor materials. It shows you how a lot of, you see these people who are having this covering the head, they have gloves, they are in white coat, they are really making sure that there is no dirt. that can interfere with what they are working on. And I have no business with that. The other one is an OR gate, where we just arrange the diodes facing this other direction. And then we have a pull down resistor here to the ground. And then we have the output Y here, which is equal to AB for the input, for these two inputs, A and B. And then the truth table, AB, Y is that we got 0, 0, 0, 0, 1, there is a 1, 1, 0, there is a 1, and then 1, 1, there is a 1, there is a high. It's nothing like two highs.
That should be plus, I think. Y is equal to A plus. A or B.
Yeah, this is A or B.
The function.
Yeah. So the diode logic is not complete because cannot realize the NOT gate. There is no way we can get a NOT gate using the diode logic. Maybe you can concoct one and see. Is there any way we can arrange the diodes to make sure that we get a NOT gate, we invert what we are having upside down? Okay, for those of you who haven't done D1 and D2, especially D1 where I do a lot of explanations and maybe you were not keen when I was explaining in class, the idea is that here we put on a resistor protecting the LED, and then we ground so that we are able to see light or no light. Light means 1, no light means 0. So if I put ground here, okay, before I put anything, with this one hanging and this one hanging, and there is a supply of 5 volts, it means that if this is hanging, there is nothing whichever flows where there is no connection. So it will be forced to come and pass here. So first round, when you switch on, then it will light, even before you put any combinations. So in the lab, I normally make it light, and then when we switch off, it normally does not go off immediately. And the explanation I give you is that when you switch on, the electrons start moving. When electrons start moving, they sweat off the light. As they are sweating off light, when you switch off, they start cooling down or leaving the sweat now. And as they do that, the sweat goes slowly. So the light keeps going off slowly until when they are all back in their vacancies. Once they have filled the vacancies, then the light goes off. Every time you want to do a combination, make sure your LED, the switch is off, so that you are not confused of electrons which we are trying to leave and sweating off, and then those ones which we are coming back, that we are still giving the light. You get a point? So now we start. We ground, current would wish to pass through where there is no problem. So this is the positive flow, and if you compare with the illustration of the diode, this was our diode, and where there is this silver line in here, the band, silver band, is our cathode. So this is the cathode, this we called it an illustration. This one was our circuit symbol. So you ground, it passes here, nothing needs to suffer to go through. Just like you guys, when you know that you can get maximum force without having to travel, that's what some of you do. Those are the electives you choose. You first ask, who is teaching that? How is he? He gives the marks, then you do that job. You avoid any hassle. You don't want problems. You want peace. Now, when you ground here and put 5 here, 5 5 will never, whatever you supply here can never go through, so it can only be here. But still, when you ground here and put 5 here, it has an option. You put 5 here and ground here, there is an option, instead of hassling there. It is only when you put 5 here and here, that is the key word. That is the key word of being AND gate. It is only when you put 5 here and here that 5s come and stage here and say, tell this other one coming, you ain't going nowhere. Even if there are problems here, face them. So then they go here and then you get the light. And that is the only light you get here. Whereas for the OR gate, when you put ground in your circuit, there is no other voltage. So you have the LED here. So when you put 5 here, ground here, 5 here, 5 will flow, and then you get. When you put here 5 and ground here, you get. This one was to protect the, in your experiment, this one is to protect this, but because we are not sure, you may start removing this, or you may forget it and kill our LED. So we make sure that it has, on one of its legs, it has a resistor to protect it. When you put 5, 5, they both flow, and then the 5, assuming this one was not there, all the 5 goes through here. And when it goes through there, that's why we need to protect. So here the key word is that you can, to get a 1, to get the LED lighting, you can either put 5 here, or put 5 here, or put on both. And that is the essence of the OR gate. And then you get these OR gates, you get these diodes, you make them in smaller sizes, you fit them in a chip, and then you make an OR gate chip. It's time to go away. Where are you going? Huh? The lecturer will come here, she will chase us, then I will go. So when she comes, make sure that you allow me. Yes. When you see her, it is open, the door is open. When you see her, just say she's here. Eh? It's okay. When you see her, I know Wamidia will tell you the truth. So that logic is not complete. The diode logic is not complete. The reason it is not complete is because it cannot realize the NOT gate. It cannot realize the NOT gate. So we do some modification. The modification we do is that we use a diode transistor logic. That is addition of a transistor as an inverter. You remember when we said that we can use a diode as a switch. So, and the simple BJT, we can, when we put in the power, when we bias the base, that current will block the IC coming, and then we have it off. Then we reduce the IB, the other one flows this way, so you can't have an output. So you supplied, you made the base high, but the output there is nothing, because nothing could what? could go there. And then you end up now saying that you are having an inverter as a transistor to complete. So the DTL has overtaken, sorry, the DTL, this struggle of adding a transistor within the diode logic has been overtaken by events. It is better we just go for transistor logic, which does everything that the diode would have used. After all, transistors are made of diodes. Has been overtaken by transistor logic, TTL. So note, I just want to make you note that so that you don't think of doing French. DTL is diode transistor logic, and TTL is transistor logic. And because electronics is too practical and too factual, at times I may not tell you to design your circuit, so you find that some of the questions are as simple as saying, write the following in full, DTL. So you need to understand that kind of scenario that we have in that sense. Has she come?
She's not coming.
She's not coming? Yes. now I can move at my pace with peace. Are you sure?
Yes.
You are going. I just want you to let me reach at a point whereby those who will do the my vibrator on today was what, Thursday, tomorrow, to be able to have the theory. That's what I'm fighting for. So that at least you do one of the practicals when you are loaded with theory. Those who have been doing it, I have been saying leave this one out. Then I have been saying this looks like the traffic lights. Then I have to show you a signpost which one of our former students made. So I've been doing a lot of politics. So I'm trying to fight to make sure that I can just relax and keep seeing how far you are going. So that because you won't say we are not knowing what we are doing, I have already what? Told it. Because people who are doing E1, I'm only concerned that I don't want them to mess up the transformer by burning it. Otherwise, there is not much that I need to explain on E1. And maybe to make sure that I can show people how the oscilloscope, that new oscilloscope works, and how to measure the peak-to-peak and other things for me. Otherwise, I wouldn't be bothered at all. The best circuit for the TTL, the best circuit is the NAND. The NAND gate containing several transistors, diodes, and resistors. And an example is that if we have a supply of 5 volts, and we have R1, Then we can have transistor 1 here with 2 inputs, A and B. 2 inputs, A and B. And then the output of this A and B be fed to this other transistor here. And this is R2. And then we will get the output at the collector. Here as Y. We are saying that this is a NAND. This is an example of a NAND, which will be A, B, bar. And this is the, so these emitters face this way, and then this emitter here, and then we have the grounding. If anyone wants, can try to explain to us what is happening. You have 5 volts coming here, and then when they come here, this, depending on the value here, these are the emitters. So you have at the collector here, so being able to, so if this is ground, everything will flow this way. Nothing will flow this other way. Then the one which is coming this way, you have supplied a 5, which is coming here, and eventually which would have been biased. If we have a bias here, we would repel and it would go up. But if you, so that means if you ground and everything went this way, what would happen here? What I'm trying to say is, how does this one become NAND? If you have 5,
if you have both of them supplied, then there is no current going this way. So then you have to go to the base, the other side, and then that side will block current going from RC.
So we would have gotten the
nothing going to be.
But then nothing going to AB.
Oh, that will.
It would be AB. Everything would have gone there. So why is it called a NAND? Why is it now producing nothing?
So for this to be off, you want no current to come through to us or what?
The question you should be answering is, how do you get an output here? Whenever we have VCC, this is what we supply, and when we supply it, it comes this way, and it would have had a chance to go that way if it is not able to get through this way. Then it can be able to go that way. So when we bias here, and we have made this reverse bias, this gate, this junction between these two diodes here at the collector base, then if you have a bias here, then everything will be repelled to this side, so you get an output. Now the question is, when you put here, whatever you put, 5, if your high is 5, you have put 5, you have put 5. Where does it flow to this way? Does it just remain here? What happens?
So when
I put 5 here, but I have also this 5 which is coming from the VCC. Comes and biases here at the base. And this is the collector. So what happens? 5 here.
If you put 5 here, there should be nothing happening. That's why the none, isn't it?
Don't be biased. Let me rub this.
Okay.
I'm rubbing that. So don't justify. Just before we justify, the idea would be that it is when you have here and here that you are able to push everything this side. That's one step. So that's the and. But what that and does when you reach here and you have, when you reach here, you have an option of, the question is, when you have this base here, base supplied here, apart from, what does this part give you? Does it give you an option of losing whatever you got this way, that there is no bias, and so also this one flows, and eventually you have nothing here. So I don't want to explain. I give this one as to find out how it becomes not. And this one gives you a chance to not to understand, but to feel. To feel how all these, a transistor, a resistor, and probably we could have put a diode somewhere just to make sure that we don't have anything coming back. And all this is now made sure it fits in a small thing, like a finger size. But even when you look at the size of the advancement of technology that I told you, these are the SD cards. And each of the black ones, each of them is 32. The red ones, each one of them is 64 GBs. And I carry them around. Now in 1849, in 1849, they show a photo. Think about that. I don't remember the exact year, but they were showing a photo of a 3 megabyte hard drive. I mean, hard disk being offloaded from a Fuso truck. Being offloaded from a Fuso truck in London. Like you bought that, you would reach it. This was, I think it was IBM. 1949. It was IBM supplying a 3 megabyte, a 3 megabyte hard disk, storage. Now, during my time, I don't know Agaba's time, they didn't have anything. During our time, we had a floppy. We had a floppy disk. A floppy disk was 1.4 megabytes.
That was a big one.
Yes, in our time, we had advanced. 1.4 megabytes. You go on the PC, you can save a letter, an application letter. I would type some tests. By then I was teaching in Vienna. I type my tests at home. I draw all the diagram. I save on a floppy. I put here. I swear. I go to school, I give the secretary print for me. She used to like me because I never used to give her a headache. Like for me, I come with my stuff done. And then she prints out, I go and give a test. 1.4 MBs, and it was prestige. This is the storage we had, and you are .com. You have 1.4 MB. Now, 1.4 MBs nowadays, if I take a selfie, that is it called DHR? No, that is just, there's a DHR option on the, when you say panorama or whatever, on the types of photos you want to take. I think it is the DHR. It is not even having any other special thing. It is just that it is the crystal clear. It's 4 MBs. One photo like this.
My floppy disk not even have, I think my thesis was 20 something
KBs. So that's how life that's how life has changed. That's how life has changed, and that's how advancement has moved on. And so that's what every time, and that's why I'm worried for our race. And those of you who were doing E7, you remember how I begged you at least to pull up your socks. If you want to make sure that you do something, really, you have to change the way you look at stuff. Yeah, because if we are still struggling in the lab to adjust oscilloscopes, others are producing big things. We are going to continue being beggars. You know, beggars in the courts. You wait for, you've seen people who fight to go for a sale, a Black Friday of sorts, when they say we are releasing an iPhone. They fight on the entrance just to buy a phone to use. You don't even know what is inside. You are just using it. So when shall we do anything?
Have all of you seen a floppy disk?
In the photos, in the photographs. They have just seen in the photographs. So, and if you look at the end, the other side, when you are going to project lab, if you are crossing to project lab, there is a cupboard, sort of a cupboard, a black cupboard. That was the main switch, full of vacuum diodes. You flip up, you flip down, things spark around, and you know now I have put power. Power goes, and when it comes back, I didn't see it. Now, those of the boys, or the gentlemen, when you are going to your toilet, sorry, your lavatory, is it called lavatories, or places of convenience, since some of you want to speak nice things. There is something you don't understand which is just under like that step. That was a fridge. That was a refrigerator. The whites who were here, that was their refrigerator. That's where they would put water and come and pick some nice cold water and take and go around posing. And that's why for me, when people are saying that we are having a colonial curriculum, I disagree. These people brought their good stuff to us, but we looked at them as stepmoms. If a stepmom looks at you, well, you think maybe they have put poison in the food. If they come and say, my son, take this. When you take a bite, you are like, to know whether there could be some poison. Because what did they bring around? We use Nerico. Is Nerico our publisher? There is Tom Duncan. There is McKee. So why don't we work hard to make sure that we understand these things, so that when we go to their land, we also know what they know. For now, we want to make the mats and the cakes so that we decolonize our curriculum. And the chapati. I'm lucky. I'm lucky that I grew up in the village, studied here in the city, had a chance to go abroad and see how those people do stuff, and came back. I've taught in fake schools, I've taught in big schools, I'm now teaching in a big university. In the arts I don't know, but in sciences, there is no biology for Africans. Digestion is the same. What you eat here, it comes out. Whether you are in China, whether you are in Europe. The phones you carry, they are modern phones. You also want sliding thing. When they are walking, they walk like this. When they are talking, they do like this. so that you see the architecture of the phone from everywhere. But when it comes to working, they say, there is this word here, this is Africa, TIA. When it comes to working hard, you say, no, this is Africa. We can be late. When it comes to luxury life, we don't say this is Africa, that we have to sleep on mats. You want a big mattress, you want a big vehicle, you want a big whatever. I don't know what is there. So the logic levels, I rubbed it. The logic levels for this NAND here, we have low being about 0.0 to 0.8 volts, and we have high being the same as 2.0 to about 5.0 volts. And those of you who have done D1, you know that one of the tables, you fill the table by... Haja, do you want to go out? Okay, I hope all is well, because I've transited from there to this one. So when you, that practical, you have to measure the voltage using the meter, the voltmeter. And the delay time to see the response of the change in states is about 10 microseconds. No, 10 nanoseconds actually. Nanoseconds is is a billionth of a second. There are two different. There are also different TTL. There are also different transistor logic families according to their speed. So they can be categorized according to speed, according to how much power they can consume. And any other characteristics that you can think of, depending on what you want to use to differentiate with. When you go for an interview, the interviewers for a job can decide to say, okay, your papers, you all have an upper, probably 4 point something, something. They say, now you have an upper, all of you. Then they say, females should be encouraged to apply. So if the two of you are females, the female will rate you immediately because of gender balance. Now I normally tell people, if you come two guys, and one is my son, and the other is you, and my son is having the same marks as yours, my son gets a job. Because if I retire, he can look after me, I don't know you. So don't complain. Use this idea of that if they are cheating you by unanimous decision, knock the head out of the guy. And let's see whether they will hold him from a knockout down there, even when he can't see, and then they hold him that he's the winner. But if you accept to compete with somebody by points, they will kick you out by other factors. So these other characteristics of how to identify these families depend on how someone looks at it and what they are preferring from a given setup. Then the other one is the mirror coupled logic. And this is a mirror coupled logic, ECL. So if I ask you write ECL in full, that's what I would be meaning. You just say mirror coupled logic, don't give me explanations. So the mirror coupled logic prevents, ECL prevents the gates transistors gets transistors from saturation. And this means that they will end up having a delay time of about 1 nanosecond. And this is really very fast. Billionths of a second, they have already given a response. But they are power monsters, but consumes more power and it is not directly compatible with the TTL and CMOS. I'm bringing a new terminology, CMOS. So what the hell is CMOS? So the CMOS logic this is the complementary monoxide, complementary peroxide, semi-character. So this CMOS logic, the CMOS logic uses peroxide semi-characters, field effect. Now I know why you answered in chorus. Field effect transistors, which are MOSFETs. Yeah, I now know the reason, because when you got this assignment, you were able to get to see those things. What are the advantages of this logic here, of CMOS? Advantages: it's very low in power consumption, very low power consumption. Any electronic device is preferred because of how much power it consumes, both in terms of being used like a phone. If you got a phone that can last like 2 days without being recharged, everyone will buy that. Yeah. No matter how you are playing movies or access, and you spend 2 days full working, but some people may just look for you and finish you, because it should be able to lose power. You use your car, lose power, use your car. This world is a cycle. If you do anything that will not make economics work, then you are a problem. People don't want peace. So you have to make sure that what you do can make some people make money in order to facilitate economics. Good noise immunity. Good noise immunity. And then they can be operated at a wide range. Operates from a wide range. From wide range power supply. It can still work when you are between 2 volts to 15 volts. You still be able to get something. Like a LED. A LED will light from whether you have put about 2 volts, okay, 5. You can still reach about 20 when it is still able to, if you have a protection. But that's not what I'm saying. What I'm saying is that these CMOS logic family gadgets or circuits, they can be able to operate in that way. That's an advantage. But there is a disadvantage. And the disadvantage is that, the disadvantages are two. You take long to see what has happened after changing the input. So the disadvantages are that they have long propagation delay time. Long propagation delay time. About 30 nanoseconds. They give you low current, so there is low output current. Now, I want you to understand, when you have low output current, you cannot use it to do some maneuvers. Now, if your inputs were supposed to be, when I put this and I put this, the output should make a beep, for example. Or like I told you, when you enter a lift, you press 5, someone presses 7, another one presses ground floor, 0, and you all stand. What you have pressed as inputs now give an output to command the lift to move. Now, that output, if the current it is giving is very low, then you cannot make it drive anything. If it is a buzzer, like a siren, and it is supposed to do, when I have this and this, it should buzz, it should make noise. So if somebody comes and finds my door locked and tries to fit it with the key, it should be able now to ignite the alarm. Then if your combination of inputs gives low output, that means you cannot harvest the output and use it for running some other gadget to give you the output indication. Now, if the output of these other 2 diodes, when we put 5, if the output was very low and it cannot make the LED light, so I can't know what I'm getting on the output. But we are able to see that this is a 1 because the LED is lighting. So if you are getting so low current that it cannot light a LED, for example, then it means that this logic will not be that much useful. But at least they are able to, depends. If you are using them for some things which are just to give you a response, and that response can be able to be seen, but with the low current, then they work out fine. I just wanted you to get a feel of that. Now, we look at the sequential logic circuits. You know this. You have seen on social media when they say 1, then 3, 5, then they say fill up the other 2 gaps. And then someone says only geniuses can do this. So you start wondering, so this is what we mean by a sequence. You know that if to get the second one, they added a 2. And also here, it is true you add a 2. So I will add a 2, I'll add a 2, and so you get a sequence. You know how it is flowing. that's why we are now going to look at the sequential logic circuits. I see people looking at their watches. This man has taken our free time. When is he going? Eh? You are hungry? Yes. You haven't done anything. You haven't eaten lunch. That's why Hajat is walking around. That is why Hajat is walking around this place in a zigzag way. But Hajat, you are used to fasting. Is it because you prepare to fast when it is fasting period, like you do? It is called one dab. You take a lot of dab and know that you are going to also the whole. But where were you coming from when you came for a lecture? I told nobody here. I'm the one who opened. You had another venue. You were in PMT. Huh? You were in PMT and then came here. Huh? No, where were you today? You were in the view. Huh? You were in curriculum.
We don't just like things.
Okay, let me just give you this sentence. I will not complain, but on the 17th May, I'll make sure that even a microsecond, when I say stop, it does not pass. Which other date? On the 16th of this month, between here, shall be here, between 14 hours and I will also make sure that at 16 or at 15, I'll make sure at 15, at 14:59, microseconds is how many? They go up 60 or 100. Let me just leave this sentence. I don't want you to collapse here. So combinational logic.
Sequential.
I have said the sequential logic circuits, but the combinational, don't worry. I'm trying to differentiate between the two of them, and then we go away. So combinational logic circuit. I understand your issues. So I am just finishing this part and then I let you. The output combination of the output depends only on its current, on its present, or on its current we mean present. So if we put ground, that's what we care about. Present inputs. E.g. logic gates. In a logic gate, we were putting ground, then we see what happens. Ground 5, we see what happens. 5 ground. Once we don't put nothing, okay, whichever we put is new. Nothing, it cannot remember anything before. The sequential, on the other hand, the sequential logic circuit ensures that the output depends on current or present, and past inputs, e.g. the flip-flops. So let's start on the multivibrator, which I thought I could do, but since you want to die, I don't want to see anyone collapsing. So we shall do multivibrators. On Tuesday. Finish all of them, because this week was 7. Next week is 14. Next week is, yeah. So I'm doing extremely well. Moving forward. Listen before you go. Learning is a process. Every experience we have, each lecture makes you remember what we studied. After all, these notes sound well. These videos are on YouTube. There are other advanced people who have YouTube lectures from MIT, from every year, Cambridge, etc. That means you could do this course on your own. You wouldn't even pay fees to come here. You pay because of this experience. See you tomorrow at 3 for the Friday group.